Hey guys, and welcome back. My name is Miss Danielson, and I hope you joined us for our previous lesson on mixed numbers and improper fractions, because we're taking it one step further today to convert mixed numbers and improper fractions into decimal values. If you missed that previous lesson, I'm linking it down in the description box for you below. Otherwise, you should be ready to get started, so let's get into it. Starting straight in with an example, just keeping in mind that fractions are just divisions. So when I see 16 over 3, I'm just thinking that's 16 divided by 3. Now, since I'm turning this fraction into a decimal value, I am going to have to do some long division here. But one important thing to keep in mind to make sure you've got your place values correctly, that is your decimal in the right place, when you divide a big number by a smaller number, as we do in top-heavy or improper fractions, the result will always be some value greater than 1. So it won't be 0 point something. So let's set up this long division. Here I've got my long division sign with the 16, which is being divided by the 3, which we're asking how many times does the 3 go into the 16? So the 3 is outside knocking on the door. How many times can I put 3 into the first digit, into the 1? No times, right? So I'm doing 3's into 16, both digits here. So I'll line my answer up above the 6 to show that this is the number of digits I've divided already. So 3's into 16, I know my 3's times table quite well. I know that 5 times 3 is 15, which is really quite close. So 5 times 3, I'll write the answer down below, is 15. And I still have something remaining, however. It wasn't perfect. 16 minus 15 is 1. In primary, we would stop here and say that our answer is just 5 remainder 1. And as we did in our last lesson, we could say as a mixed number, our answer is 5 and 1 over 3, 5 and 1/3. But since we're trying to write this as a decimal, let's keep going. Now, 3's into 16 is the same thing as 3's into 16.0. I can put as many zeros up here as I need, but remember we put a decimal there. This is not 3's into 160. So I line up my answer with a decimal in the answer as well. So I'm doing 3's into, taking down that 0, 10. How many 3's go into 10? Again, knowing your 3's times table quite well, I know that 3 times 3 gets close to 10 without going over. 3 times 3 is 9. And I'll have something left over. 10 take away the 9. I've got a remainder of 1. Notice something special here. I've got the same remainder as I had the last time. Let's just make sure that this isn't some kind of weird mistake. If I take down another 0, I'll have a 10 down here again, and I'll do how many 3's go into 10? 3 3's. That gets me as close as I can get. That's 9. And I subtract the 9, and I see my remainder again is 1. So I must have a recurring decimal in my answer here. I could either round this to one decimal place, so 5 point, and that digit after the decimal point is a 3, and there's a 3 after it, so it's not going to round up. I would say that 16 divided by 3 is approximately 5.3 to one decimal place. As you see, I've used the approximately equal to sign because I've rounded my answer. It's not exact. I could have also written my answer with an equal sign, so the exact answer is 5.3 recurring. But keep in mind that it's difficult to put 5.3 recurring into a calculator. If you needed to do further calculations, you would probably be better off using the fractional format of this answer. And then when you get to your final answer, you can convert it to a decimal and either round or write it as a recurring decimal. So that was converting a top-heavy fraction into a decimal. What about converting mixed numbers to decimals? Now don't worry, this is actually easier than what we've just done. Just remember that fractions are divisions again, but mixed numbers have already got a whole number part, and the fractional part is not a top-heavy fraction. So 5 3/4 could be written as 5 point, and we'll just work out what 3/4 is, which we know, since the numerator is smaller than the denominator, will be 0 point something. So we already know the whole number part. As a mixed number, we have a whole number part and a fractional part. So the 3/4, or the 3 divided by 4, is going to tell us what comes after that decimal. So let's set up this long division. I'm doing 3 divided by 4, so 3 is inside the house, and I want to know how many 4s go into it. Since we're starting with a fraction which is not a top-heavy fraction, I know my answer is not going to be greater than 1. It's going to be 0 point something, and I can see that in the first step of my long division. I do how many 4s are there in 3, and there are 0 4s in 3 because 1 times 4 is already too big. So I put a 0 over top of the 3, and then I do as we did in our last example. I can put a decimal after this 3, and I put a 0 after that decimal. 3.0 has the same value as 3, but I'm going to treat this as if it's 30. I'm going to do 4s into 30, and I know my 4s times table quite well. 4 times 6 is 24. 4 times 7 is 28. 4 times 8 is 32, but that's too big. So let's start writing our answer in here. Line up the decimal point as we've got in the question. It goes lined up with the answer. And I said 7 4s will fit into 30. 7 times 4 is 28. And it's not perfect. I will have a remainder, but it's as close as we can get. We've got 0 take away 8 we can't do, so we'll borrow from over here and we'll do 10 take away 8. That's 2. And now here we're not doing 3 take away 2 because we borrowed from here, leaving 2 behind. 2 minus 2 is 0. So I've got a remainder of 2. You probably knew that 30 minus 28 is 2. So if we've got a remainder, we need to keep going. So I'm going to put another 0 up here. After this decimal point, I can put as many zeros as I need. Let's take down that 0, and let's do 4s into 20. This time I can get an exact answer. I know my 4s times tables quite well, and I know that 5 times 4 is equal to 20 exactly. So 5 times 4 is 20. If I subtract that, I get a remainder of 0. So don't forget your answers up here at the top. Our answer is 0.75. So we know that 5 3/4 is the same thing as 5.75, our answer from our long division. Let's go into some practice now. Here are some mixed numbers, which I want you to convert into decimals. Remember, these are the easier ones to do because we already know what the whole number is. For question 1, for example, we know it's 4 point something. For question 2, we know it's 3 point something, and so on. Go ahead and hit pause now and give that a go, and push play when you're ready to take it up. I hope you had a chance to hit pause, because here come your answers. For question 1, that's going to be 4 1/4. That's a fraction that you should know. That's 4.25. For question 2, 3 2/3, again, you may know this one, or you might have had to do a long division for it. It's 3.6 recurring. For question 3, fractions with a denominator of 7 are always tricky, so I'll bet this was a long division for you. It's 3.571428, and if you keep going, you'll see that after the 8 comes another 571428. So this is a recurring decimal as well, but it's got 6 recurring digits. So we show that with a line over all of the recurring digits to show that all of them repeat in that order. For question 4, 5 1/2 should have been an easy fraction for you to know. That's 5.5. Question 5 should be easy as well. Question 6 as well. Question 7 as well. Question 8 as well. 9. Question 10, when you've got a fraction with a denominator of 9, very often that's a recurring decimal as well. I wonder if anybody could tell me down in the comment section if they know the rule for fractions with a denominator of 9. This one is 4.1 recurring. Just the one recurs. For question 8, that should be a fairly straightforward one. 8.4. For question 12, again, a third should be a fraction that you know is a decimal. That's 4.3 recurring. And question 15 is the same as question 10. 4.1 recurring. Let's go on to converting improper fractions to decimals now. You may want to start by turning these improper fractions into mixed numbers and then converting those mixed numbers into decimals. That will save you from doing long divisions with bigger numbers. All right, so hit pause now, copy this out, show you're working, and hit play when you're ready to take it up. I hope you had a chance to hit pause. Here come your answers. For question 1, I know I can do 55 divided by 11, that would be 5. So this answer is going to be 5 point something. 5.27 recurring. That's the 2, and then the 7, and then a 2 again, and then a 7 again. Question 2, again, I know I could do 12 divided by 4, that would be 3. So this is going to be 3 point something. 3.25. Question 3, I know 24 divided by 6 is 4, so this should be 4 point something. 4.6, recurring. Question 4, I know that 16 divided by 4 is 4, so this is 4.75. Question 5, and again, that long recurring decimal answer. Did you notice the pattern? 714,285, then back to 7 again, 14285. Notice the pattern in these recurring digits and the patterns in question 6. Can anybody tell me what the pattern in the recurring digits is when we've got a denominator of 7 in the top-heavy fraction? Question 7, 7.3 recurring. Question 8, 5.4. Question 9, 10, 11, 12, 13, 14, and 15. Now, how did that go for you? Hopefully it was fairly straightforward, but I hope you found this lesson interesting and helpful. Please let me know down in the comment section if you have any doubts or difficulties. Otherwise, keep practicing, and I'll see you soon for our next lesson.